All right, so we are also going to record the meeting just for posterity, so that, if there are any other students who might not have been able to make it to the class, we are able to give them something worthwhile. If you're having any problems hearing me, please let me know in the chat or open your mic and, tell me.
No, sir, we're hearing.
All right. Any question? If there are any questions, please raise your hand. Okay, click the raise hand icon, and in good time, I will acknowledge you, and you can have your say. All right, good. So I know that you guys love math, right? You're all math lovers here. We've had our difficulty with mathematics, but it's not been to the point where we say we have given up on it and we don't want anything else to do with it in life ever again. All right, so I'm going to assume that this is everyone. I'm going to assume that this is everyone. Go ahead. All right, so as I was saying, I'm going to go ahead and assume that this is everyone, and we are going to start. We're going to start a question. We're going to start some questions here. I have some past paper questions from 2021, right? We are going to work through the questions. We're going to work through the questions in reasonable time. I want you to attempt as many as you can first. If you guys have any ideas or alternatives as to how this question might be done, right? Please feel free to share. All right. I'm not going to hit you over the head, right? Or bash you in any way. We're here to learn and reason together how to best solve our problems, right? Especially math, because math always give us problems to solve, like them can't solve their own problems, right? So that's what we're gonna do. So the questions all have marks, and hopefully we know that the number of marks indicate the number of minutes that it should take for us to complete the question, right? Hopefully that is the case. All right, so let's begin. So this one's, we can use a calculator or otherwise, right? If we have a problem, hopefully we all have a scientific calculator with us, right? If there's a problem, you don't know how to use a scientific calculator or how to get these figures onto your scientific calculator, let me know. All right, I am fairly adept with most calculators. I'm not going to say I'm an expert, right? Because some calculators might elude me, right? Especially if I've never seen it before. So with regards to the Texas Instrument, the Casio, and other brands similar to the Casio, we're fine. All right. Of course, if they give you the answer, they'll give it to you as a fraction, then they expect an answer in a fraction. Okay, so 2 minutes for this. I will give you the 2 minutes, and then we will reconvene. All right, so we should be about done. First, let us get the use of the calculator out of the way. So if we're using our calculator, I would, well, first let's look at some of the signs. For the Texas Instrument, I know that there's a fraction sign that looks basically like some squares. Usually the fraction sign is in the form A, and you have B over C, something like that. Or maybe it is AX over Y, but you know, it hardly changes. It hardly changes. On the Texas Instrument, let me start, because you know that's my calculator. I like Texas Instrument. So on the Texas Instrument, once you press this symbol or the corresponding symbol, it will give us some squares. All right, it will give us some squares in which we will input our numbers. So we'll just input our numbers, press the symbol again, you find the operation, click the operation, and continue, right? And as you work it out, you press the equal sign, and the answer appears. So that's it for the Texas Instrument. On the Casio or other instruments like the Casio, you might see AB over C, and when you press the AB over C symbol, it looks like a little L, and this L would mean over. So if I want to, so on the calculator, if I want to say 1 and 4 over 7, I would press 1 fraction sign, that would give me that little symbol there. Press the 4 fraction sign over 7, right? I fully advocate the use of brackets, right? And we always follow, I call it PEMDAS. Other people might call it BOMDAS or BODMAS, but I prefer to call it PEMDAS, right? PEMDAS for parentheses, exponents, multiplication, division, addition, subtraction, right? Multiplication, division, addition, subtraction, right? So we follow the rules of PEMDAS, order of operations, all the time. If you don't remember it, that's one of the first things you write off in the exam, right? The order of operations, or anything that you find that you might have difficulty remembering. That's the first. Those are some of the very first things you write off in the exam. Okay, so we use PEMDAS, parentheses, multiplication, addition, subtraction. and we work this out. If we were just using our calculator, that would be fine. You insert the numbers as they appear, you know, and you would get your answer. For those of us who don't have any calculators, I really hope that everybody would have a calculator, but just in case you don't have a calculator, my first option would be to convert all mixed numbers into improper fractions, right? Convert the mixed numbers or mixed fractions into improper fractions. If we have a mixed fraction, A, B over C, when we convert it to an improper fraction, when we convert this to an improper fraction, it will be A times C plus B all over C, right? And that would give us our improper fraction. So 1 and 4 over 7 is equal to 1 times 7 plus 4 over 7, which is equal to 11 over 7. We have 1 and 5 over 7, which would, so that would say that 1 and 5 over 7 would be equal to 12 over 7, but using the same method. And then we just use these to help us to answer the question. So we have 11 over 7 divided by 2 over 3 minus 12 over 7. Now remember that according to PEMDAS, the parentheses, exponents, multiplication, division, addition, and subtraction, I would have to do this. This is first. So this is first. It's an S, then a T. This is second. Both of these are third. And then both of these are fourth. Okay. So we are going to do them in descending order. So let's do them in descending order. So we would have to do our division before we do our subtractions, right? Do our division before we do our subtraction. I advise showing working wherever possible. As it says, all working must be clearly shown. So I would show working wherever possible. Put this part on your calculator first. So 11 over 7 divided by 2 over 3. That would give us, well, we know that we're supposed to keep the first fraction, keep the fraction on the left, change the symbol on the right, and then flip the fraction on the right-hand side. Okay. That's how we do division of fractions. Keep the number on the left, or keep the term on the left, change the symbol from divide to multiply, and then flip. F is for flip the one on the right. So this would look something like 11 over 7 times 3 over 2. Yeah. And we don't worry. I try not to worry about that. That looks normal. That would give us 11 times 3. We'll just multiply straight across over 7 times 2, which would give us 33 over 14. Right? I prefer to get the fraction first and then reduce it afterwards. Okay, it's a lot less stress for me. Hopefully it's a lot less stress for you. If you find that it is easier for you to cancel vertically and diagonally before you multiply, that's fine. I find it easier to multiply horizontally first and then reduce if possible. Right? So if it's possible to reduce, we reduce it. If it's not possible, I already have a mark, I move on. Okay. That being said, getting to this point will give you, or should give you, a mark. Getting to that point should give you a mark. So now we have, so now the question becomes 33 over 14 minus, we had 1 and 5 over 7, that is the mixed number, but the improper fraction for that is 12 over 7. Okay, now we're subtracting, we're not multiplying, we're not adding, we're subtracting, as according to PEMDAS, after we do our multiplication or division, we now need to add or subtract if possible. So now that we're subtracting, we have different LCM, sorry, denominators. We have different denominators. We need an LCM. Gave away the answer there. All right, we need an LCM. And just to remind us that this is the LCM, I just put a little LCM. We need a common denominator here. We need a common denominator, which is the LCM, so that we are able to add or subtract normally. Okay. LCM of 7 and 14. So we want the smallest number that both 14 and 7 can divide, right? Both 14 and 7 can divide 14. So both 14 and 7 can divide 14. 14 divided by 14 is 1, gives us 33. So 14 divided by 7 is 2. 2 times 12 is 24. That looks to be about 9. So our final answer is 9 over 14. Okay, we don't have to, we don't have to take that long, right? With all the extra talking, we might have taken up a bit of extra time. Okay, but so far, are there any questions?
No, sir.
All right. All right, and that will be this will also be our next mark. Okay. Of course, we could have just all put this in our calculator and got 9 over 14. CSEC would still more than likely give you full marks because you're following the instructions of using a calculator or otherwise. Okay. All right. I'm about to clear the drawings. And let's move on to the next question. Let's move on to the next question. Okay. Let's give yourself some time to work this out. That's 1 mark. So when Megan started working, she was paid $85 a week. After a 6-month probationary period, her pay was increased by 20%. How much was she paid each week after the increase? Typically a 1 mark question. So 1 mark, 1 minute, or rather 30 seconds. But let's give you, since it's a mark per minute, let's go with that. Entonces, clase, vamos a continuar. All right, let's continue class. All right, in class, let's continue. So whenever we're reading these questions, we want to highlight some of the important things it said, right? So when she started working, she was paid $85. That's important. $85 each week. That's important. Her pay was increased. Her pay increased by 20%. Right? When was it increased? So now the question is asking us, how much was she paid after the increase? So how much is she paid after the increase? Right? You want to make some underlining, or you want to highlight some parts of the question so that you're able to answer it properly. Okay. All right, so we know that she was paid $85 each week. And that was increased by 20%. There are two ways we can do this. So we have method one, method two. Please forgive my atrocious handwriting. That's why I'm speaking as I write. Okay, so method one is the normal. So, well, I guess they're both normal. Method one is like, okay, so we know it increased by 20%. 20% of what? 20% of 85, right? So we know it increased by 20% of 85. And of course, we know that the symbol 20% means 20 out of 100, because that's what the word percent literally means. For each 100. So it's 20 for each 100. Of in mathematics means multiply, and of course this is 85 over 1, right? Any whole number that we get, we can simply change it into a fraction by dividing it by 1. I would then multiply across. I would then actually multiply across. So this is 20 times 85 divided by 100. Divided by 100, which is equal to 2 5s 10, 2 8s 16, and 117 over 100. So it's now 170 divided by 100, which is equal to 1.7 or $1.70. So this is the increase, but this is not how much he's paid, right? This is our increase, but not how much he is paid. So how much is he now paid? We would have to add the increase to the base number, right? She is paid 85 plus 1.70, which is equal to $86.70, right? That is how much she will be paid.
Excuse me, sir.
Go ahead.
So when I put the digits into my calculator, so when I said 85 times 20, so I got 1,700.
1,700?
Yes, sir.
Thank you very much. Okay, so that would make this 17. Thank you. Good. Thank you for following along with me. So this is $17. So the pay is increased by $17. 17 plus 85, 7 plus 5 is 2, carry 1, that's 100, so $102.
Yes, sir.
All right, thank you very much. All right. Good. So this is one way we can do it. Find out how much it increases by, and then add the increase to the base pay. Method 2 is kind of a shortcut of that. First we establish that the base pay is 100%. So $85 is her base pay, and that is akin to 100%. Okay, that's how much she started originally. And then we now say, so since this is the base pay, if we increase 100 by 20%, if we increase 100 by 20%, we get 120%. So how much money would that be? All right, how much money would that be? So we just find 120% of 85, which is 120 divided by 100 multiplied by 85 over 1. Put it in the calculator the same way. So it's 120 times 85 divided by 100, which still gives you $102. Right? So either way you work it, it is perfectly fine. Sorry about that. Either way you work it, it is perfectly fine. And the answer is right. It's just how, it would just be how we reason it. Okay. It's really and truly how it is reasoned. Okay. What about the second one? Before we start answering the second one, we would need to know what are significant figures, right? So in a population in 1965 and 2015, so 2015 has a population of this 3,663,900, and in 1965, the population was 2,714,000. So what is a significant figure? Right? There are three main rules to significant figures. One, the first rule is any non-zero number is significant. Right? So any number that is not zero, that's significant. Okay. Two, any zero between, sorry, any zero that is found between two significant figures is also significant. Right? Any zero found between two significant figures is also significant. And last but certainly not least, any zero that is found to be behind a natural number and a decimal point is also significant. Right? And those are the three main rules. Right? There are some people who say leading zeros and lagging zeros, right? Those are just more specific rules for number three, for rule number three. Yes?
Could you repeat the third rule, because I'm not, the screen is logging on my end.
The screen is? All right, I'm going to share screen. I'm going to share screen. There we go. So the three rules are any non-zero digit is always significant. So 1, 2, 3, as long as it's not a zero, it is significant. Right? Any zero that is between two significant figures is also significant. Like, you know, you have that, you don't have, but you have seen that one person who has two cool friends. You wonder, how are you all friends? Right? You don't have any special talents and they do, but you're friends with them. So that person becomes significant. All right. Right. And finally, any zero that comes after a decimal point and after a whole number, sorry, and after a natural number is significant. Okay, so these zeros are significant because they appear after a decimal point and after a whole number. Same here, after decimal point, after a whole number. So those are significant. These ones are not significant because even though they come after a decimal point, there is no natural number. Same thing for the number 200. Number 200, it comes after a whole number, but there's no decimal point. So these zeros are not significant. Okay? And those are the three basic rules for finding significant figures. Right? Even if you have a number in scientific notation or standard form, scientific notation / standard form, let us say the number is, for those of us who are doing chemistry, is 6.02 times 10 to the 23rd power, right? There are only 3 significant figures here. We can ignore the rest of these zeros. We can ignore the exponent and just count the number of significant figures that you see there. And I gave away the answer again. Oh, Jesus. How many significant figures do we have here? We have this is 1, that is 2, and this 0 is between 2 significant figures, so it becomes significant by association. So we have 3 significant figures here. We just write that 3 significant figures, right? So you can ignore the number of zeros there. All right. Let's get back to the question. Let's move back to the question. So moving back to the question, it says there is a population of 3,663,900, and we want to write this figure correct to 3 significant figures. Well, first, let's identify our 3 significant figures. All right? Let's identify our 3 significant figures. Well, that's not 0, so that is significant. That's not 0, so that's significant. And this is also not 0, so that's significant. So those are my first 3 significant figures. What's the next thing to do? So now that I have my first 3 significant figures, I need to look, quote unquote, so we're going to look right next door. Look. So look right next door, which will reveal this number here, 3. Okay. Now, if the number is what? 4 or less, let it rest, right? If the number is 4 or less, we are going to convert all the other numbers to 0. If the number is 5 or more, we would increase the number immediately to the left by 1, or increase the number to the immediate left by 1 if it was 5 or more. So, but because this is 3, which is 4 or less, we're going to round it down. So we're going to round it down, and our answer will be 3660, and all other numbers after that also become 0. So our answer is 3,660,000. Right? And that's correct to 3 significant figures. 3 sig. That's supposed to be a G. 3 significant figures. Right? Okay. Any questions? All right, so no questions. Let's move on. Let's clear these drawings and move on to, I know that we want to move on to something more difficult, but let's see how far we can get. And then by the next class, we should be able to complete this, this paper, right? All right. So it says write the population of 1965 in standard form. Standard form, aka, well, as far as I know, it is also scientific notation, right? So scientific notation is also a term that we can use. The general form is a decimal. Then we have some more numbers here, multiplied by 10 to the nth power, right? And a is not 0, right? A is any number between any number between 1 and 9. So 1 is less than or equal to a less than or equal to 9. All right, it's not 0 and it can't be 10, but it must be a whole number, a natural number between 1 and 9. Let's take a quick look at the I believe it was 2 million something, but let's take a quick look at the number. So number is 2714 then 000. Okay, and we're going to write that number in, scientific notation or standard form. Okay, so when we're writing in standard form, we want to identify where the decimal point is. Since this is a whole number, we assume that the decimal point is, well, no, the decimal point is comes after the units. Okay, so it comes after the units. We are going to move this decimal point so we need to move this decimal point so that we can get it behind one of the whole numbers, right? Now, we don't stop it at the first whole number. We don't stop it at the first whole number that it gets to, because it needs to be in the form a decimal point and then some other numbers behind it, right? So we need to have only one whole number to the left of the decimal point. That's why we're moving it until we come to only one decimal point here, right? Only one number to the left of it, because we need only one number to the left of the decimal point. So this is going to be 2 point, let's write everything else, 2.714. Zeros are not significant. We don't need to put them in. Multiplied by 10. 10 to the what? Well, the n is equal to the number of times we move the decimal point. Right? Decimal point is moved. That's what n is. Okay. And also the sign of n is positive when we move the decimal point to the left and negative when we move the decimal point to the right. That's something that we should know, right? So n is positive when we move the decimal point to the left in this case, and it is right when we move, sorry, it is negative when we move decimal point to the right when we're dealing with standard form. Okay. How many times did we move it? We moved it 1, 2, 3, 4, 5, 6 times. We moved it 6 times. Is n positive or negative? Well, we moved it to the left, so n is positive. And this is our final answer. All right. Okay. Give you a second with that, and then we move on. All right, let's move on. Thank God for recordings, right? If only you could record your face-to-face classes as well. You know, be a lot less trouble. Maybe. Just maybe. Okay. The next one says determine the percentage increase in the population from 1965 to 2015. Remember that the population in 2015, the population was 366,390, and in 1965 it was I don't remember, so we need to go back and look for it. It was 2,714,000. Yes.
100 something.
100. 2,714. 2714. 271,400. Okay. So that's what it was. All right, so we need the percentage increase. So if we are going to have a percentage increase, would I use 2015 as my original date or 1965 as my original date?
In 1960.
Sorry, I didn't hear that one.
So I said the original 1965.
Right, so we would use 1965 as our original date. Okay. So we're going to see how much it increased from 1965. Let's find the difference though. So the difference between the difference in the population is 366,390 minus 271,400. Blah blah blah. 9. I'm going to assume that's a 4. This is also a 9. And this is 2 7s 14 and 115. I got 549,900. Could have also used a calculator, mind you. That's why, that's why God inspired man to make calculators, so that some of these things would definitely be easier for us. My calculator said this is 900. Yes, that's true. 949,000. My bad. 900. So we increased by almost 1 million. So it's 949,000. So to determine the percentage increase now, we're going to take the difference. So 949, 900. Right? Divide that by the original date, which is 2714,000. Multiply that by 100. $27,14,000. Right.
So I got 35%.
35% is the correct answer. All right. And that's it. All right. All right. So we are nearing the end. There are several things that I want to do. We're nearing the end. Sorry. There are several things that I want to do. First, I am going to slowly go through the rest of this paper so that when you go through it in the recording, you're able to see the questions, pause the video, try the questions. Right? So you pause when you get the recording, pause the video, try the questions. When we come back, hit me with your best shot. Okay? Anything that you don't know, you don't understand, please don't be afraid to ask. I'm not seeing your face, so I can't laugh at you. No one else here will laugh at you. Okay, we're all here to learn.
Sir, 1 minute. Could you go back to the other one, please?
Remember that you're going to get a recording, You're going to get a recording, so you'll be able to see it as you go. You can pause it as you go. You're taking screenshots, aren't you? Okay. All right. Okay.
You can continue.
Excuse me, sir. So how will the recording be shown on the platform? So will it be sent to our email or somewhere else?
I believe that one-on-one educational services will send it to you on the platform. Speaking of which, let me also share with you the link. So there is a link that I'm going to be putting in the chat. If you haven't already, registered, one-on-one services will send it to you. So please register. Okay. Is this the link? Yes, copy. Chat. Paste. Enter. Okay. So that is the link. Copy it. Go through it. In the chat. Okay. All right, and we're scrolling down. Back in my day, they didn't give you this graph, you know. They would tell you to create the graph and then draw it. So that's a good thing now. You get a graph all to yourself. All right, ladies and gentlemen, that would be it for tonight. I will see you guys again next time, where I hope we will be able to conclude this this paper. Right, it's quite a bit ahead of us, but if you come with your questions, come with having done some questions and with your answers, you know, I'll be able to quickly sort out where we are falling short. Go ahead. All right. So if there are no questions, ladies and gentlemen, we can dismiss. Have yourselves a wonderful evening. Take care. Keep safe.